Topic 14, Nuclear Physics. Part 3, Nuclear Reactions. Nuclear reactions. There are different types of nuclear reactions, and they can be broadly divided into 3 different types here. The first one is nuclear active decay, which occurs in nature. The second one is fission, which is normally an artificial process. The best example is a nuclear bomb, or what's going on inside the nuclear reactor. The third type is called fusion. It can be artificial, like in the case of hydrogen bomb, or it can occur in nature, like what's going on in our sun. In all cases, the nucleon number, proton number, and energy mass are all conserved, which means they are the same before and after nuclear reaction. During a radioactive decay, an alpha particle could be given off, or a beta particle could be given off, or gamma radiation could be given off. Notice alpha is a particle, not radiation. Beta is also a particle, not radiation. Only gamma is true radiation. And also, alpha has got 2 protons and 2 neutrons. Beta is simply an electron. Let's revisit the 3 types of radiation. Alpha, which is simply helium nucleus because it has 2 protons and 2 neutrons. But because it has lost 2 electrons, the overall charge is positive 2 plus 2. Beta is simply electron, so the charge is negative 1. And this electron is originated in the nucleus, not from outside the nucleus. One of the electrons splits to become a proton and an electron, and this electron is now called beta. Gamma rays consist of photons, i.e. light of very short wavelength. This table here lists some of the properties of these 3 types of radiation. Charge, alpha is positive 2, as you've seen. Beta is negative 1, gamma having no charge. Speed, alpha can travel at about 10% the speed of light. Beta, being much smaller and lighter, can travel up to 90% speed of light. And gamma, being part of light, travels at the speed of light. Penetration, alpha can penetrate a piece of paper. Beta can penetrate half a centimeter thickness of aluminium. And gamma, being the most penetrative, can penetrate 20 centimeters of lead. Ionizing ability or ionizing effect, alpha is high, beta is medium, gamma is low. Out of this radioactive sample come the 3 types of radiation, alpha, beta, gamma. And when they go through an electric field set up by 2 oppositely charged plates, they behave differently. As you can see, alpha being positive gets drawn to the negative plate. Beta being negative gets drawn to the positive plate. And gamma, having no charge, will go straight through. This slide here shows the same thing as the previous slide, except in a different way. Here is a pictorial illustration of the degree of penetration by each of these 3 types of radiation. Firstly, alpha particle being the most massive can be stopped by a piece of paper. Secondly, beta being much smaller can go through a piece of paper but can be stopped by a thick piece of aluminium. Gamma can go through paper and aluminium easily, but can only be stopped by a thick piece of lead. This is simply telling you what ionization means. When an alpha or beta particle collides with an A molecule, it could knock an electron from the A molecule. And occasionally, gamma rays also do that. This gives a summary of natural radioactive decay. First of all, it is spontaneous decay of a nucleus with the emission of either an alpha particle or a beta particle, but not both, and usually accompanied by the emission of gamma radiation. And radioactive decay is both spontaneous, happening by itself, and random. No particular pattern cannot be predicted. Here is an example of alpha decay. A uranium nucleus, being unstable, splits into two smaller particles, and one of them is alpha particle. Now, what is important for you to know is the numbers on both sides of the reaction are balanced. So 238 being the mass number is equal to 4 plus 234. The atomic number or proton number of 92 on this side is equal to 2 plus 90. Here is an example of beta decay. The parent nucleus is thorium. It splits into two smaller particles. One of them is beta or electron. And then the other particle, being protactinium, is unstable. So it gives off a gamma photon to become a more stable nucleus. Now try balancing these equations of nuclear reactions. You don't have to know what these elements are. You just have to balance these numbers. I'll do the first one with you. This 260 here, the mass number on this side, must be equal to 205 plus 55, obviously, to give 260. So the mass number of this newly formed element must be 55. And for the atomic number or proton number, here we have 104, must be equal to 81 plus 23 here. So straight away you can determine these two unknown numbers. Very easy. You can do the rest. Now try balancing these equations. First of all, you have to write an equation for each of these. For example, the first one here, this must be split into two smaller particles, and one of them must be an alpha. And you can work out what the other one is by balancing the numbers, and so on with these three other equations. There are some more here for you to do.